Lesson 3. Solve absolute value equations and inequalities. Absolute values is the distance from the origin to a coordinate. Usually you think about it because we're in one dimension usually, it just makes the number positive. But technically, the absolute value of x, these vertical lines here are absolute value marks. Absolute value of x is b, where b is the distance between x and 0. The origin is 0. If you have it as absolute value of x minus k is b, it means the distance between x and k is b. So how do you solve an absolute value equation? Well, you write two equations. One with the absolute value expression positive and one where it's negative, because we don't know if what was in that absolute value is positive or negative. I mean, if it's a positive 3, it's 3. But if it was a negative 3 in the absolute value, it's still 3. So we have to take both the options of it's positive or negative. You solve each equation, check your solutions. It is possible to solve everything correctly and get a wrong answer. Those are called extraneous solutions. So we can have extraneous solutions. All right, so let's try solving x, absolute value of x minus 3 equals 10. All right, so our first one, the x minus 3 is positive. Our other equation, the x minus 3 is negative. I know this is probably different than how you learned it in elementary school or even Algebra 1, but in the end, this makes the most sense. Add 3 to both sides, you get 13. So then you could either distribute the negative, or I'm going to divide by negative 1 first. And then I'll add 3, and I get x is negative 7. Now remember, this meant that the distance between x and 3 is 10. Well, between 13 and 3 is 10. Between negative 7 and 3 is also 10. Try plugging them in. So if I plug in a 13, I get 10 equals 10. Let's try plugging in the negative 7. Hey, that'll work too. So they're both correct answers. Let's try another one. So the value of 2x plus 5 equals 3x. All right, let's take our first equation where everything's just positive in the absolute value. And then our other equation where the absolute value stuff is negative. Solve each of them. The first one, let's get the x's together. So 5 equals x. Second one, we can either distribute the negative or divide by the negative. I'm going to just divide by the negative. Let's get the x's together. So 5 equals negative 5x. Divide by the negative 5 to get the x by itself, so I get negative 1. And now I have to check. So let's check with the 5. So 2 times 5 plus 5 is 3 times 5. So 2 times 5 is 10 plus 5 is 15. Does that equal 15? Yes, it does. All right, let's try the negative 1. 2 times negative 1 plus 5 equals 3 times negative 1. 2 times negative 1 is negative 2 plus 5 is 3. So I get 3 equals negative 3. No, no, that doesn't work. So negative 1 is not an answer. Only 5 is an answer. And folks, that is why you need to check your answers. This one is extraneous. All right, let's try another one. A little bit longer this time. Same process though. Start with the absolute value part being positive, or the absolute value part being negative. All right, start with the positive side and solve this one. Let's get the x's together. Solve 2x minus 1 equals 9. I'll get things away from the x, so we'll add 1. Then divide by the 2, so x is 5. All right, on the other equation, let's maybe distribute the negative first. So negative 4x plus 1. Let's get the x's together. So negative 6x plus 1 equals 9. Subtract the 1, negative 6x equals 8. Divide by the negative 6. Now we can reduce this fraction by 2, so it'll be negative 4/3. All right, so now you get to plug that in your calculator and see if they work. So check your answers. Believe they both work when you plug them back in. But what if it's an inequality instead of an equation? Well, same thing, except for we're going to combine our answers into a compound inequality. So that's like 2 is less than x is less than 5, or maybe if x is less than 2, or x is greater than 5, depending on whether it's between the 2 points or going away from the 2 points, if you graph them on a number line. Let's see how it works. All right, let's start with this one. Solve 2x minus 7 is greater than 1. All right, two equations or inequalities. First one where the absolute value stuff is positive. The second one where the absolute value stuff is negative. Again, probably saying that's not how I learned it in elementary school, but it works better and gets the same thing. It's easier to understand why what happens. All right, let's solve the first one. So I'm going to add 7 to get the x's by itself. Divide by 2, so I'll get x is greater than 4. This other one, if I divide by a negative 1, it's going to flip the sign around because I divided by a negative. Then I'll add my 7. And divide by 2. So I get x is less than 3. Now you need to think to yourself, are there numbers greater than 4 and less than 3? If we were to put this on a number line, here's the 4 and x is greater than 4. Here's the 3 and x is less than 3. Notice they're going opposite directions. They do not overlap. So our compound inequality is x is less than 3 or x is greater than 4. If they overlapped, we would have to combine them like this first way up there. Let's try another one. Same process. First equation or inequality, the absolute value stuff is positive. Second one, absolute value stuff is negative. All right, the first one, let's subtract 7 to get the x by itself. Then we need to divide by negative 1. Remember, when you divide by a negative, you have to flip the inequality around. So the one I think I'm going to distribute the negative. That'll give me a positive x. Then add 7. So I get x is greater than 3 or x is less than or equal to 11. So if I think of a number line, here's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, x is greater than or equal to 3. It's filled in because it's equal to. We're going that way. It's less than or equal to 11. I'm going to go smaller numbers. Notice they're going to overlap, so it's just between those two. So since there are numbers that are both greater than 3 and less than 11, you would write it like this. In manufacturing, the word tolerance is used to describe the amount of allowed difference between real-life measurements and the expected standard. We could write it out like this. The actual minus the standard in absolute value, so the distance between the actual and the standard is less than or equal to the tolerance. Now this isn't technically manufacturing, but ostrich eggs have an average mass of 1,950 grams with a tolerance of 350 grams. Write and solve an absolute value inequality that describes the mass of the ostrich eggs. All right. We want the actual, so our actual is going to be the x. Our standard is what it should be or usually is, the 1,950. So this is our standard. And that's the tolerance, 350. So that's our inequality. So now we just have to solve. First inequality, absolute value stuff is positive. Or the second inequality, the absolute value stuff is negative. Solve for x. And you get 2,300. I'm going to divide by the -1. I think that will keep my x positive. When I divide by a negative, switch the inequality around. Then I'll add the 1950 to get the x by itself, and that gets me 1,600. Now, are the numbers bigger than 1,600 and smaller than 2,300? Why, of course there are. Here's 1,600, here's 2,000, here's 2,300. So we've got first one going that way, second one going that way. So it looks like our answer is 1,600 grams. It's an equal x, less than or equal to 2,300 grams. So the egg is between 1,600 grams and 2,300 grams.